All right, welcome to our trig review. We are trying to get ready for the ACT and MCA tests that are coming up in April. First question here says find the missing side lengths. So this is just a quick review of the Pythagorean Theorem that says when you have a right triangle, if you square the two legs and add that together, it's equal to the square of the hypotenuse. So the first thing to notice here, the side opposite the right angle is always our hypotenuse, the longest side. The other two sides will be our legs, or in this case, a 20 and some unknown. I'll call it x. So the Pythagorean theorem says if we take 20 squared and x squared, add them together, we should get the hypotenuse squared, so 25 squared. Squaring, we get 400 and 625. So then when we subtract our 400, x squared equals 225. And when we square root that, x would be 15. So our missing side length is 15. For the second one here, it's just a quick review of a proportion where we have a fraction equal to a fraction. A lot of times in trig, we end up with proportions. So just a quick review of how to solve that. 3 times 2x plus 7 is equivalent to 9 times x plus 1. Many of you think of this as cross multiplying. Distributing our 3, we get 6x plus 21. On the right side, we get 9x plus 9. And then getting x's to one side, we can subtract our 6x to get 3 on the right. We can subtract our 9, and we get 12. So 12 equals 3x. So, dividing out the 3, we get x is 4. All right, so looking at some trig, with our right triangles here, it's important to focus on where that angle is. In this case, theta is in the bottom right corner here, which means the side that we look at as we face out from that angle is our opposite side. The side that is right next to it is our adjacent side. And then remember, the side opposite the right angle is always your hypotenuse, which will be the longest side. So we have 6 trig functions, but there's 3 that are the main ones: sine, cosine, and tangent. And sine is defined as opposite over hypotenuse. Cosine is defined as adjacent over hypotenuse. And tangent is opposite over adjacent. So we're dividing these, we're creating a ratio of these side lengths. To help us remember that, we think of the phrase SOHCAHTOA. The so part here means the sine is opposite divided by hypotenuse. Our cosine is adjacent divided by hypotenuse, and our tangent is opposite divided by adjacent. So our example here says to find the values of the 3 trig functions. In order to do that, we need to know all the sides, and we only know 2. So we are going to go through our Pythagorean theorem, just like we did with that first example today. And so we plug in our 6 and our 8 for our a's and b's. We square them, add it together, we get 100. And then when we square root, we get 10. So our unknown here is 10. And now that we have all 3 sides labeled, we can set up our ratios. So we said sine was opposite divided by hypotenuse. Okay, well, for angle theta, 6 is going to be the opposite side, and the hypotenuse would be the 10. All right, the 8 is our adjacent side, the one right next to our angle. So for sine, we would say opposite over hypotenuse, or 6 divided by 10. You can leave that as a fraction. You could reduce it to 3/5. You could convert it to the decimal. Cosine would be adjacent over hypotenuse, so 8 divided by 10, or again 4/5 or 0.8. And tangent is opposite over adjacent, so 6/8 or 3/4, or the decimal 0.75. We do have some common Pythagorean triples that it will save you some time on that ACT test if you remember. A 3, 4, 5 triangle where the legs are 3 and 4 and the hypotenuse is 5 is a pretty typical one. We also have 5, 12, 13, and 7, 24, 25 as common Pythagorean triples. All right, so we want to find the value of our three trig functions. Once again, we are missing one of the side lengths, so go ahead and pause the video and turn it back on when you're ready to check. All right, checking. Pythagorean theorem says if we take 12 squared plus some unknown side length squared, we should get 13 squared. So 144 plus x squared should be 169. When we subtract, x squared comes out to be 25, which means our missing side length must have been a 5. All right, so to set up our sine, again, we need to label our sides. For angle theta, 5 is going to be our opposite, 13 is our hypotenuse, and 12 is our adjacent. Okay, so sine is going to be opposite over hypotenuse, or 5/13. Cosine should be adjacent over hypotenuse, so 12/13. And then tangent is opposite over adjacent, so 5/12. All right, find the values of the other two trig functions if we know that the cosine of theta is 3/7. So they're giving me two of the side lengths, and we just have to remember that cosine means adjacent divided by hypotenuse. Okay, so my adjacent side to angle theta is here. My hypotenuse is here. All right, so we know that this side is 3 and that side has to be a 7. And once we know that, we can go through that Pythagorean theorem again to find our missing side. Plugging in our 3 and 7, remember the 7 has to go in for C. We square them, move our 9 to the other side. So we end up with x squared equals 40, square rooting, and then we could simplify that to be 2 times the square root of 10. We're basically splitting this into 4 and 10. All right, so we know that our missing side here is 2√10, and now we can set up our trig functions. Sine is going to be opposite over hypotenuse, so 2√10 divided by 7. Cosine is going to be adjacent over hypotenuse. We already were given that, 3/7. And tangent opposite over adjacent. So 2√10 divided by 3. Okay, we are now going to shift to using our calculator to help us find the trig functions for some given angles. We are going to round to the nearest 10,000th, which is 4 decimal places, right? Tenths, hundredths, thousandths, 10,000ths. But the thing to remember here is on our calculators, we have to make sure that it is set up correctly. So go to your mode key and then double check that you have degree here highlighted. The default setting for our calculators is radians. So a lot of times for testing, they have you reset them. You'll need to make sure you go back and switch it back to degrees. All right, so we want to use the calculator to find the sine of 45. So on our calculator, we'll quit out of that. We're going to type sine. Our trig functions are right here. So we're going to use sine of 45. We've already set it to be in degrees. And so we end up with set 0.7071067812. So we want to cut that off after 4 decimal places. So to do that, we always look at the 5th number now and decide if it's 5 or higher, we're going to round up. Since this one isn't, we would just chunk this all off. And our answer would be 0.7071. Okay, our second one, they want cosine of 53 degrees. So again, cosine key and then 53. Again, we're going to chop it off after 4 decimals. Since this is a 1, it's not 5 or higher, we drop that off. Our answer is 0.6018. So I'm going to have you pause the video for a minute, and then we will come back and check these 4 answers. Go ahead and do them on your calculator. All right, checking. Okay, tangent of 75, you should have 3.8321. Tangent of 25, 0.4663, and cosine of 8 is 0.9903. All right, our next one says to find x in each of the triangles. So we are given an angle. We are given one unknown side and one known side. That's enough to figure it out, but we have to decide which sides we're working with. So for angle 23, x would be our opposite and 18 would be our hypotenuse. And the trig function that goes with opposite and hypotenuse is sine. So we would say the sine of 23 degrees has to be opposite over hypotenuse. And then to solve for x, we're simply going to multiply the 18 over. So 18 times the sine of 23 degrees should get us our x value. So let's check on our calculator. We want 18 times the sine of 23 degrees, and we get an answer of 7.0332. All right, go ahead and pause the video and try the next one. Okay, checking our answer. For this next one, again, opposite of 42 is this x, and hypotenuse is 18. So once again, we would say the sine of 42 degrees should be x divided by 18. So to find x, we have to multiply the 18 over to the other side. All right, and then using your calculator, you should have ended up with x being 12.0444. Okay. Find x in each of these triangles. Again, we're given one side, one unknown side, and a given angle. Identifying our sides here. This one is opposite, and this one is adjacent. So which trig function uses opposite and adjacent? That would be tangent. So we can say the tangent of 77 degrees should be opposite 65 divided by x, our adjacent side. And what's different about this one now is our variable's in the denominator. So we're going to have to multiply that variable over to this side. So x times the tangent of 77 degrees should equal 65. And then tangent of 77 is just a decimal number. So we can divide that out. So we're going to take 65 divided by the tangent of 77 degrees. All right, 65 divided by tangent 77. So our side is 15.0064. All right, go ahead and pause the video and try the next one. Okay, let's check our answer. For this one, 21 would be the adjacent side to angle 31, and our unknown this time is our hypotenuse. So the trig function that works with those two side lengths would be cosine. The cosine of 31 degrees should be adjacent over hypotenuse. Once again, you're going to have to multiply that x over and then divide our trig function here. So x equals 21 divided by the cosine of 31 degrees. If you did that on your calculator, you should have had x being 24.4993. Okay, so let's move on here. What if we don't know the angle? In all of the trig examples we've used so far, we've been given an angle to use, so we could find the sine of, say, 36 degrees. But what if we don't know the angle? In that case, we use what's called inverse trig functions. So this is going to look on your calculator like this: sine inverse, cosine inverse, tangent inverse. So to do those, you're actually going to be using second sine to get the inverse. Okay, so we're going to use a calculator to evaluate these. If it says the sine of x equals 7/12, then what we're going to put in our calculator is inverse sine of 7/12 should give us x. So we're undoing a sine by doing an inverse sine. So on our calculator, what that would look like. Let's get rid of these here. So notice above sine, cosine, and tangent, we have these inverse functions. Okay, so we're going to hit second sine to get the inverse sine, and we're using the fraction 7/12. So 7 divided by 12. Okay, so what it's giving us now is an angle measurement. So we've got an angle of 35.7 roughly. Okay. For the next one, it says the cosine of x of some unknown angle is 3/11. That means to find x, we're going to have to do inverse cosine of 3/11. So once again, second cosine to get inverse cosine of 3 divided by 11. And we end up with an angle of 74.2 if we would round that. So go ahead and pause the video, try the next two. Okay, checking our answers. For this one, we would have to do the inverse tangent of 17/4, which should have come out to be 76.8 degrees, and inverse cosine of 7/12, that should have come out to be 54.3 degrees. Okay, so we're going to use that for these two triangles. We want to find the missing angle. So once again, we have to determine which sides we're working with. This is opposite, and this is hypotenuse. That means we're using a sine function. So the sine of x is opposite divided by hypotenuse, 10/17. So to find our unknown angle, we have to do inverse sine of 10/17. All right, grab your calculator. Inverse sine of, what did we have, 10/17. My screen is just a little off here. There we go. 10 divided by 17. Okay, and we've got an angle now of 36.03 degrees. Okay, go ahead and try the next one. Checking that. This side is the adjacent side, and we have 14 for our hypotenuse. So we should set up the cosine of x degrees would be 9 divided by 14, which means x is going to have to be the inverse cosine of 9/14. And if we do that on the calculator, inverse cosine of 9/14, we end up with x being 49.995. Again, if we tried to round that a little bit more, it would really round all the way up to 50 degrees. Okay, so we're going to solve this triangle. Now, solving a triangle means we're finding all the missing sides and angles, all of them. So the first thing to do is to kind of think about, given this angle 19, how would we mark our sides? Opposite would be this side A, adjacent would be our 13, and C would be our hypotenuse. Okay? Now, one way we can find the missing angle is we know that the angles have to add up to 180. And since one of our angles is already given as a 90-degree angle, we know that the other two have to add up to the other 90 degrees. So we can simply take 90 minus 19 and get our missing angle here is 71 degrees. Okay? Now, to find our sides, we only know one side. So we're going to have to use some trig to find our missing side. Since it's a side we're looking for, we don't need our inverse trig functions. We just need our normal ones. Based on the 19, now even though I figured out that this is 71, in case I did a math error, let's go ahead and try to work with the given information. They told us this was a 19-degree angle, so using that, we can say tangent of 19 would be A divided by 13. And then to find A, we simply have to multiply our 13 over. So 13 times the tangent of 19 typed in our calculator would give us 4.48. So go ahead and try to find the cosine of 19. Set up that fraction. So cosine of 19 now uses opposite over hypotenuse. So 13 divided by c. And then to find c, we simply have to multiply it to this side. So we've got c times the cosine of 19 equals 13. And then we can divide the cosine back over. So 13 divided by the cosine of 19 should come out to be 13.75. Okay, here's another one where we're solving our triangle. The difference here is we're given 2 of the 3 sides, but only one angle, the 90-degree angle. So we can't find an angle right away. We're going to have to figure out our sides first. Since we know 2, we can use Pythagorean Theorem. So a squared plus b squared should equal c squared. In this case, a is 8, b is 14, or the other way around, it doesn't matter. Squaring those and adding them together, we get 260. And then to find c, we have to square root that. We can break it down a little bit. We could think of that as 4 times 65. So we end up with 2 square root of 65 for our hypotenuse. Okay, now that we have all of our sides marked, let's start with angle x. If we're trying to find angle x, we're going to have to use an inverse trig function. But we know all 3 sides. I'm going to go ahead again and use the 2 that we were originally given, just in case I made a mistake. For angle x, 14 would be the opposite side, and 8 would be the adjacent side. So we could say tangent of x degrees is opposite over adjacent. So to find x, we would have to do inverse tangent of 14 divided by 8. Grabbing our calculators, inverse tangent of 14 divided by 8 comes out to be 60.26 if we were to round that. Now to find angle y, we have 2 options. We could know that this is now 60.26, this is 90 degrees. We can figure out the missing one because they all have to add up to 180, or these 2 alone have to add up to the other 90 since we already have 90 degrees here. So if we did that, we would get y plus the 60.26 has to be 90 degrees. Subtracting it over, we end up with 29.74 degrees. Okay. We could also have used a trig function to figure that out. We could have set up to find angle y opposite over adjacent. So the tangent of y would be 8 divided by 14. So y would be the inverse tangent of 8/14. It's going to get you to that same answer we had there. All right, the last little piece that we're going to look at today reviews what we call angle of depression and angle of elevation. We have horizontal lines here. If you think back to your geometry, horizontal lines cut by a transversal. All right, so we have parallel lines cut by a transversal. Alternate interior angles here need to be equal. So that tells me that the angle of elevation and the angle of depression are the same value. We refer to it as angle of elevation if we are low looking up at a higher point. We call it an angle of depression if we're high and we're looking down to a lower point. All right, so it says a man is standing 30 feet from a water tower and looks up at an angle of 66 degrees to see the top of the tower. how tall is the tower? So looking at our picture here, it says he's standing 30 feet from the water tower. So the man is right here, and this is our tower. Okay, so he's 30 feet away. It says, how tall is the tower? So we're trying to find this unknown x, the height. Based on my angle, it says there he's looking up 66 degrees. So that's an angle of elevation to get up to seeing the top of the tower there. Using angle 66, we would call side x our opposite side. We would call side 30 here our adjacent, and that is our hypotenuse, which we're not actually going to even need for this problem because we're just asked to find the height. We're finding x. So the trig function that uses opposite and adjacent would be our tangent. So we can set up the tangent of 66 degrees should equal x divided by 30, opposite divided by adjacent, and then simply multiply our 30 to the other side. So 30 times the tangent of 66 degrees will get us our unknown height. And then if we use our calculator, we would get 67.4. And this was measured in feet for the horizontal distance, so this would also be feet. So that water tower is 67.4 feet tall. All right, so the last question that we're going to look at, it says an airplane is flying at 20,000 feet. It's headed towards an airport. The airport's landing system sends radar signals from the runway to the airplane at a 5-degree angle of elevation. How many miles measured along the ground is the airplane from the runway? Okay, so we've got the airplane here, the runway here. Okay, that's where it starts, and this is the airplane. And from the end of the runway here, angle of elevation up to the plane is 5 degrees. So we are trying to figure out this horizontal distance. They did tell us that the plane is flying at 20,000 feet, so we know the height of the plane is 20,000 feet. And based on using that angle that's 5 degrees, we know this would be our opposite side, this would be our adjacent side, and that would be our hypotenuse. So let's figure out our trig function using opposite here and trying to find this unknown adjacent side. We would have to use a tangent function. So we can say the tangent of 5 degrees would be 20,000 divided by x. Multiplying our x over, x times the tangent of 5 degrees is 20,000. That means that x is going to be 20,000 divided by the tangent of 5 degrees. Now, that ends up being a really, really large number, but we're measuring this in feet, which might not be real practical. So let's think about this, that 1 mile is equivalent to 5,280 feet. So we can take our answer here, the 20,000 divided by tangent of 5, ends up being 228,601 feet. If we divide that by 5,280, then we can get this in terms of miles. So our horizontal distance is actually 43.3 miles. Okay, hopefully that is a good review of all of our trig information for your ACT and MCA tests.